Welcome to the Explainer. So today we're diving into the master plan, the blueprint behind pretty much every piece of complex software you use. It's called software modeling, and we're going to get familiar with its universal language, UML.
All right, let's kick things off with a simple question. Would you ever build a house without a blueprint? No way, right? You've got to know where the walls go, how the plumbing's going to run, how everything fits together. You need all that before you lay a single brick.
Well, that exact same logic, it applies to building software. You know, these really complex applications, they need a solid plan to prevent absolute chaos, to save time, and to avoid super costly mistakes down the line. And that plan, that's what we call a model.
So, what is software modeling really at its core? Well, it's just the process of creating these simplified representations, yeah, those blueprints we were just talking about, of a software system. It's all about visualizing the structure, the behavior, everything about the software before you even think about writing the first line of code.
And I love this quote because it just perfectly captures the difference. A design, that might just be a rough idea, like a quick sketch on a napkin. But modeling is the real engineering step that makes sure all those little details are actually going to work together.
But, not all blueprints are created equal. You can have a plan for an entire neighborhood, or you can have one for just a single house. And software modeling, it makes a very similar distinction. Okay, so this table really breaks it down for us. On one side, you have system modeling. Think of this as the super wide-angle view. It includes people, hardware, all the real-world processes, like an entire hospital system. But then you've got software modeling, which zooms right in on just the code itself, like the specific patient management software that runs inside that hospital.
Okay, so if we're all going to be drawing these software blueprints, how do we make sure we're all, speaking the same visual language, right? How do you make sure that a square means the same thing to a developer in Tokyo as it does to one in Toronto?
Well, the answer is UML, the Unified Modeling Language. Seriously, just think of it as the international standard for software blueprints. It gives everyone a common set of symbols and notations so that anyone, literally anywhere, can look at a model and get exactly how a system is supposed to work. And this is really why UML is so powerful. You know the saying, a picture is worth 1,000 words? It's so true here. By showing a complex system visually, teams can communicate way more clearly. And, this is a big one, they can spot potential design flaws long before they turn into really expensive problems to fix.
And look, UML isn't some new fly-by-night trend. This thing has a real history, starting way back in the mid-90s. It got adopted pretty quickly as a standard by all the major tech players, and eventually it even became an official international ISO standard. So yeah, it's a mature, totally proven tool. Now, UML isn't just one single giant diagram. It's more like a whole toolkit with different types of diagrams for different jobs. And they pretty much all fall into two main categories, ones that show the system's structure and ones that show its behavior. Yeah, a really simple way to think about this is nouns versus verbs. Structural diagrams, they describe the nouns of your system, all the static pieces, the components. Then you have behavioral diagrams, which describe the verbs, the interactions, the dynamic processes. So one is the architecture itself, and the other is how things actually move and operate within that architecture.
Okay, so let's check out a classic example of a structural diagram, the class diagram. Honestly, this is one of the most fundamental, most important diagrams in all of UML. It's basically the blueprint that shows you the core building blocks of your system and exactly how they all relate to one another. So you can see here, each of these boxes or classes has its name right at the top. Then in the middle, you have its attributes, its data. And at the bottom, you have its functions, or what it can actually do. And by connecting all these boxes, you're literally creating a static map of your entire software system. It's super clear. All right, now let's flip to the other side of the coin, a behavioral diagram. And a perfect example of this is the activity diagram. So if the class diagram we just saw is the static floor plan, the activity diagram is like a dynamic flowchart. It shows you exactly how a process unfolds, from the very beginning to the very end. This one right here shows a content publishing workflow. See how it maps out the different people involved, the author, the editor, the publisher, and the exact sequence of their actions. You can literally trace the flow. You see the decision points. You even see loops, like when a draft needs to be sent back for revision. This is modeling the system in action.
But all of this kind of begs an important question, right? In today's world of super fast, rapid development, does this kind of detailed upfront planning still even have a place?
I mean, today, so many software teams are working in an agile environment. And agile really emphasizes flexibility over doing a ton of design work up front. So, where does something like UML fit into that picture?
Right. The whole idea behind the agile model is developing in these short, rapid, incremental cycles. The goal is to avoid getting bogged down in huge long-term planning sessions. Instead, you build, you test, and you review in small, manageable chunks. So here's the crucial point. Even in a fast-paced agile world, the core benefits of UML are actually more important than ever. It's not about creating these massive, rigid documents that no one ever looks at. It's about making sure you have clear communication, better collaboration, and some consistent documentation so that the entire team is on the same page and moving in the same direction. And ultimately, that really is the key takeaway here. Using UML isn't about slowing down development with a bunch of bureaucracy. It's about using a shared visual language to create clarity and a shared understanding. And that, in the long run, actually leads to faster, more effective development. And so that leaves us with one final thought. In a world that's always pushing for more speed, what's the real price we pay for not having a clear plan from the start? Thanks for watching.